In this video, let's go ahead and practice factoring trinomials, but in these particular practice problems, the a value is going to be greater than 1, or the leading coefficient is going to be greater than 1. To help simplify factoring these types of trinomials, I broke them down into 4 different cases. Let's take a look at the first case. This is case number 1, where a is going to be positive, b is going to be positive, and c is going to be positive. For number 1, we have 2x squared plus 11x plus 5. So notice how everything is going to be positive here. Positive 2, positive 11, and positive 5. Then what we're going to do is we take a look at this first term, or this 2x squared, and we find factors of it. Now 2 is prime, so this is really just going to be 2x and 1x. So it's going to be 2x and 1x. If you multiply them, you get 2x squared. Then you take a look at this 5 at the end, and it's prime, so you really only have 5 and 1. So in this case, this is going to be nice and straightforward. At this point, you can go either across or diagonal with multiplication. Because we want to get this 11 in the middle, let's go ahead and just multiply across, because 2x times 5 is going to be 10x, and 1x times 1 is going to be 1x. So if we go ahead and pair these up in our binomials, we should get something that will factor. So first we're going to have this 2x, and then we're going to have another binomial that will start with a 1x, or just x. And the 2x is going to pair with a 5, so we're actually going to pair that over here, put the 5 out here, and put the 1 over here. So where are the pairs coming from? Well, the 2x and the 5, the pairs are the outers and the inners. So it doesn't matter which one's which, as long as one's outer and one's inner. So again, this 2x and 5 being paired together, being multiplied, those are going to be our outers or the inners if you choose to make them that. And this 1x times 1 are going to be the inners in my case, but you can make the outers if you want to as well. Let's go ahead and just check this real quick. 2x times x, that is going to be 2x to the second power, or 2x squared. Then we have 2x multiplied by 5, that's going to be plus 10x. Then we have 1 times x, this is just going to be 1x, or just x. And then finally we have 1 times 5, which is just going to be a positive 5. Then if we go ahead and combine these middle terms here, this 10x plus 1x, that should be 11x, so we get 2x squared plus 11x plus 5. That seems to check out, so we know we did a good job. Here is number 2. For number 2, we have this 3x squared plus 11x plus 6. Let's take a look at this 3x squared first. Now 3 is prime, so this should make that one easier. It's going to be 3x and 1x. That multiplies to get 3x squared. Now 6 is composite, so we really could have 3 and 2, or 6 and 1. I generally try to choose the numbers that are closer together first, so I'm going to try 3 and 2. And let's see if we can pair these up. If we go across here, this will be 3x times 3, it's 9x. 1x times 2, it's 2x. So 9x plus 2x does get you the 11x in the middle. So I'm going to go ahead and pair these up. These will be our outers, and these will be our inners, just like that. So let's go ahead and pair these up. I'm going to go ahead and put this 3x, and then I'm going to go ahead and open our second parentheses, which is going to be 1x. And then see what pairs together here. 3x is going to pair with a 3. That's going to be the outers, and the 1x is going to pair with the 2, which are our inners. So here's the outers, and here are the inners. Then if we multiply this 3x times 3 and 2 times x, the outers are going to get you that 9x that we were hoping for, and the 2 times x is 2x. And then finally, this 2 times 3 on bottom is going to be this 6. If we go ahead and combine those like terms in the middle, 9x plus 2x is 11x, so we get 3x squared plus 11x plus 6. Seems to work out. For number 3, we have this 2x squared plus 13x plus 15. If we look at this 2x squared, 2 is prime, so we know it has to be 2x and 1x. I'm going to put those first. Now for 15, it could be 3 and 5, or it could be 15 and 1. But we have to find 13 in the middle, so I'm going to start with 5 and 3 in the middle, just because they're closer together. And if we check this going across, 2x times 5 is 10x, 1x times 3 is 3x, so 10x plus 3x does equal 13x. So I'm going to make these our outers and these our inners. Okay, so let's go ahead and put this 2x at the beginning of the first binomial, and then 1x in front of the next binomial. And then the 2x is going to pair with a 5, and the 1x is going to pair with a 3. All right, so again, the 2x is pairing with a 5 here, and the 3 is pairing with the 1x, so those are outers and those are inners. If we go ahead and check this, 2x times x, that's going to be 2x to the second power. Then if we check our outers, that's going to be 10x and 3x. Let's go ahead and say that's going to be plus 10x plus 3x. And then if we check the last, then 3 times 5, that's going to be 15. Go ahead and combine those like terms in the middle. If we do that, we end up with 2x to the second power plus 13x plus 15. All right, and it seems to work out, so we're good. For number 4, we have 3x squared plus 25x plus 8. So 3, this is a prime number, so again, this takes a little bit of thinking out here for us. So it's going to be 3x and 1x. We know there's going to be the beginning of our binomials. Now 8 is composite, so it could be 1 and 8 or 2 and 4. If we start with 2 and 4, let's see what happens here. If we multiply across, that'll be 6x and 4x. If you add those, you get 10x, which is not 25x, so that doesn't work. And if we go diagonal, that's 12x and 2x, which makes 14x, which is also not 25x in the middle, so this doesn't work. 3 and 1 have to stay the same just because 3 was prime. But maybe for 8, let's, instead of choosing 4 and 2, let's choose 8 and 1. Okay, if we go across here, this will be 24x and 1x, which does make that 25x. So these will be our outers and these will be our inners. Okay, so let's go ahead and set this up. Let's have 3x at the beginning of this binomial, and let's put 1x in front of this binomial. The 3 is going to pair with the 8, so those are going to be the outers, and the 1 was on the inners. All right, so 3x and 8, those paired up, and then the 1 and x paired up here as well. If we want to check this to see if we factored correctly, 3x times x, that's going to be 3x to the second power. Then if we do the outers and the inners, that's going to be 24x and 1x. And then if we do the last 1 times 8, that's just going to be 8. If we go ahead and combine those like terms in the middle, 24x plus 1x, that's going to be 3x squared plus 25x plus 8. All right, cool. Seems to work out, so let's try another. If we look at number 5, for number 5 we have this 18x squared plus 53x plus 20. Now 18 is a composite number, so this is the first time we have to think about other factors. 1 and 18, 2 and 9, 6 and 3. So I'm going to start with 6x and 3x. I like choosing the factors closer together, and if we have to change it, we can. Now for 20, we have 1 and 20, 2 and 10, 4 and 5. So I'm going to go with a 4 and a 5 to start here, okay? And this might not work. Let's go ahead and try it. 6x times 4, that's 24, and this is going to be 15. 24 plus 15 is 39. That's not what we're looking for. If we go across here, this will be 30x and 12x. That makes, what, 42x, so that's not what we want either. Let's go ahead and maybe change the factors at the beginning here. So instead of 6 and 3, let's try maybe 9 and 2. Let's give it a try. This will get you 36, and this will get you 10. 36 plus 10 is 46x, which is not what we're looking for. If we go diagonal here, this is going to be 8 and 45. 8 and 45 do get you 53, so this works out here. So let's make these our outers, and let's make these our inners. All right, so let's go ahead and factor this, and let's put 9x over here, and then let's go ahead and put 2x over here. 9x is going to pair with the 5, and the 2x is going to pair with that positive 4. So we check this, then our outers here, that's going to be 45x, and our inners is going to be 8x, so 45 and 8 does make that 53. If we want to just check this, we can FOIL it out. 9x times 2x, that's going to be 18x to the second power. The outers, if we multiply, that's 45 and 8, so we have 45x and 8x. And then if we multiply this 5 and 4 together at the end, that's going to be 20. If we go ahead and combine these like terms in the middle here, we're going to get 18x squared plus 53x plus 20. And I think that works out. All right, last one of these types. Let's check out number 6. We have 12x squared plus 41x plus 35. Now 12 is a composite number, so let's go ahead and see if we can think of 1 and 12, or we can think of 2 and 6, or 3 and 4. I'm going to start with 4 and 3 just because they're closer together, and then we'll work our way out if we need to. For 35, we have 1 and 35. We also have 5 and 7. So 5 and 7 are closer together. I'm going to try those ones first. If we go across here, this will be 20x and this will be 21x. 20 plus 21 is 41. I like that. So let's go ahead and pair these up. So our first binomial will have a 4x to start. Our next binomial will have a 3x to start. So it's kind of nice we got on the first try here. The 4x is going to pair with the 5 on the outers, and the 3x will pair with the 7 for the inners. So these are the outers and these are the inners. If we go ahead and check this to see if we factored correctly, multiplying these, we're going to get 12x to the second power. If we do the outers and the inners, 5 times 4 is 20, so we should have 20x. On the inners, 7 times 3 is 21, that's 21x. And then finally, the 7 times 5 is 35. If we go ahead and combine those like terms in the middle, 20 plus 21 is 41, so we have 12x squared plus 41x plus 35. Seems to work out, so we factored correctly. All right, so now that we've tried a few of these types of cases where everything is positive, including A, B, and C, let's try another case. In this particular case, or what I'm calling case number 2 here, A is going to be positive, but this time B is negative, but C is going to stay positive here. Okay, so it's going to be pretty similar to case number 1. You'll see maybe why we're doing this one next. But let's go ahead and try number 7, where we have 2x squared minus 17x plus this 30. Now 2x squared, we don't have to worry too much about this. It's prime, which is nice. So we're going to have 2x and 1x. That's not going to change. Now over here we have this positive 30. Now to get positive 30, we need 2 positives, or we could also have 2 negatives. Because B is negative for all of these cases, we actually need 2 negatives because a negative plus a negative is a negative. So for 30, we're not going to use positive, we're going to use negative factors. So I'm thinking negative 1, negative 30, negative 2, negative 15, negative 3, negative 10, or negative 5, negative 6. I like choosing the ones that start closer together first and work our way out. So I'm going to start with negative 5 and negative 6. If we pair this up here, cross will be negative 10 and negative 6x. That makes negative 16, which is close, but not what we want. If we go diagonal, this is going to be negative 12 and negative 5, which does add to get negative 17. So I'm going to decide that these will be our outers and these will be our inners. Okay, your choice in terms of which one are which. Let's go ahead and say this is 2x is going to be the beginning of this binomial, and then 1x is going to be the beginning of this binomial. Now the 2x is supposed to pair with a negative 6, so we're going to put a minus 6 here, and the 1x is pairing with a negative 5, so let's put a minus 5 here. Again, this was our outers or our pairs, and this was our inners. Let's see if we factored correctly. So 2x times x, that is going to be 2x to the second power. Then if we do our outers and our inners, that's negative 12x, so it's going to be a minus 12x on the outers, and then a minus 5x for the inners. And then finally we have a negative 5 times negative 6, which is going to be a positive 30. We can go ahead and combine those like terms in the middle, negative 12 and negative 5, as we were hoping and planned, combine to make negative 17x. So that works out. Cool. I think that is good. So let's go ahead and check out number 8. For number 8, we have this 3x squared minus 19x plus 30. Now 3 is prime, so we know this has to be 3x and 1x, okay? And this 30 is going to be composite. So we know it's not going to be 5 and 6 or negative 5 and negative 6 just because we couldn't get negative 19 last time. So maybe we'll start with 3 and 10. So maybe we'll start with negative 3 and negative 10. Remember, for all of these, we need 2 negative numbers to get the negative b value in the middle. If we go across here, this is going to be negative 9 and negative 10, which does combine to make negative 19. So that kind of worked out for us. I'm going to call this my outers and these my inners. If we go ahead and do that, then I'll put 3x over here, and I'll put 1x in front of this one. The 3x is pairing with a negative 3, so let's make those our outers, and the 1x is pairing with a negative 10. So these are the outers, and these are the inners. If we go ahead and check this, 3x times x, that works out to be 3x to the second power. That's good. Then let's check our outers and our inners here. So on the outers, we have negative 9x. On the inners, we have negative 10x. And then for the last, the negative 10 times negative 3, that's going to be a positive 30. Okay, so we just went ahead and FOILed this or multiplied it out, and let's combine the like terms. If we do that, we get 3x squared minus this 19x, and then plus 30. Looks like everything worked out well, so we must have factored correctly. All right. For number 9, we have this 5x squared minus 18x plus 16. Now 5 is prime, which is good for us. We like that, so we're just going to do 5x and 1x. 16 is composite, so we have to do some more thinking here. We are going to choose 2 negatives, so negative 1, negative 16, or negative 2, negative 8, or negative 4, negative 4. Let's start with trying negative 4 and negative 4. If we do this, this will be negative 20 and negative 4, which makes negative 24. We don't need to go diagonal because the negative 4s are the same, so this doesn't work. We can't change the 5 and 1 just because 5's prime, so it has to be 5 and 1. So let's maybe try 2 and 8, or negative 2 and negative 8. If we do that, we're going to get negative 10 over here and negative 8, which do combine to make negative 18. So let's go ahead and call this our outers and this our inners. And this should work. Let's go ahead and take this 5x and 1x. Now the 5x is being paired with that minus 2, and that 1x is being paired with that minus 8. So if you want to see those pairings here, that's 5x and the negative 2, and here's the x with the negative 8. We want to check this. 5x times x, it's going to be 5x squared. And then let's go ahead and check the outers and the inners. On the outers, we're going to get negative 10x. On the inners, we're going to get negative 8x. And then for the last negative 8 times negative 2, that's going to be a positive 16. If we go ahead and combine those like terms in the middle, we're going to get 5x squared in front, and then we're going to have a minus 18x, and then a plus 16. So this seems to work out. Okay. For number 10, we have 8x squared minus 73x plus 9. So unfortunately, 8 is a composite number, so we may not have just 1 and 8. It could be also 2 and 4. Let's try 1 and 8 first. So let's do 8x and 1x. And then let's see, for the 9, we have either 1 and 9 or 3 and 3. Let's start with the ones closer together. Let's do negative 3 and negative 3. This will be negative 24 and negative 3, which makes negative 27, which isn't what we're looking for here. So let's go ahead and try something else. If you go diagonal, it's not going to change because the negative 3s are the same. I'm going to go ahead and actually change the 3 and 3 to 9 and 1. So this negative 72 and negative 1 make negative 73. Okay. If we go ahead and write out the factored form here, we're going to have 8x in the beginning of this binomial, and we're going to have 1x at the beginning of this binomial. 8x is being paired with this minus 9, and the 1x being paired with that minus 1. So our outers here are this pairing and this pairing. Let's go ahead and check it. 8x times just 1x, that is going to be 8x to the second power. Let's check the outers and the inners here. The outers is going to be negative 72x, and the inners is going to be negative 1x. If we just go ahead and just write negative x, that's fine. And then we can go ahead and check this negative 1 times negative 9. That's going to be a positive 9. Go ahead and combine negative 72x and negative 1x. That's going to be 8x squared minus 73x plus 9. Okay, so that is good to go. Let's check out number 11. For number 11, we have 15x squared minus 56x plus 20. A little bit tricky here with that 15. I'm going to start with 3x and 5x. And if we need to change it to 15 and 1, we can do that a little later. And then for this 20, we have 1 and 20, 2 and 10, 4 and 5. Let's go with a negative 4 and a negative 5. Don't forget they have to be negative because b is negative. If we go across here, this is going to be negative 12 and negative 25, which makes negative 37. That's not what we want. If we go diagonal, this is going to be negative 15 and negative 20, which is negative 35. That's also not what we want. So what are we going to change here? I'm going to go ahead and change the 4 and 5. Let's make it 2 and 10. Let's see if that helps. This will be negative 6 and negative 50. Oh, which is negative 56. So that's kind of nice here. So that'll be our outers. That'll be our inners. Let's go ahead and open these binomials up. So we have 3x at the beginning of this one and 5x at the beginning of this one. Now the 3x is going to pair with what? That minus 2. And that 5x is going to pair with that minus 10. So you can see here that these are outers, that pairing, and these are inners, or that pairing. Let's go ahead and check this. 3x times 5x, that's going to be 15x squared. Check the outers, then check the inners. On the outers, we're going to get negative 6x, and on the inners, we're going to get negative 50x. And then finally, this negative 10 times negative 2 will be a positive 20. So the negative 6 and negative 50 coefficients can be combined. For those like terms, we have 15x squared minus the 56x plus the 20. Cool, so this seems to work, so we factored correctly. All right, last one here of this type. So for number 12, we have 20x squared minus 48x plus 27. So for 20, we got a lot of factors here. 1 and 20, 2 and 10, 4 and 5. I'm going to start with 4 and 5, just because they're the closest ones together. And then for 27, we have 1 and 27, 3 and 9. Let's go with -3 and -9 and see if this works. So this will be -12 and -45, which combines to make -57. That's not what we want. This will be -36 and -15, which makes -51, which is not what we want either. Let's go ahead and maybe choose, let's change the 4 and 5. Let's change those to maybe 2 and 10 and see if that helps at all. So 2 and 10 make 20 again as well. So let's see, this is going to be -6 and -90. So that's -96. That's way too far away. This will be -18 and -30, which does make -48. Okay, so that's good. This will be our outers, and these will be our inners. Let's go ahead and set up this binomial. So we have 2x at the beginning of this one, and we'll have 10x at the beginning of our other binomial. The 2x is pairing with a -9, and the 10x is pairing with a -3. So our outers are right over here, and our inners are right over here. And let's go ahead and check this. 2x times 10x, that's this 20x to the second power. Let's go ahead and check the outers and the inners. For the outers, we're going to get -18x. For the inners, we're going to get -30x. And then if we do this -3 times -9, that's going to be a +27. If we go ahead and combine these middle terms here, we're going to have 20x to the second power minus this 48x, and then plus this 27. And that seems to be what we started with, so we did a good job factoring. All right, so 2 cases down. Let's go ahead and check out the last 2 cases, 3 and 4. These ones are similar to each other, but are a little different than 1 and 2. So let's take a look at these. Okay, so for case number 3, this is where A is going to be positive, but B is going to be positive, and then C is going to be negative. All right, so let's check out these types of problems and see how they're a little bit different. For number 13, we have 3x squared plus 17x minus 6. Now 3 is prime here, so this is not going to really change too much compared to the others. So we have 3x and 1x here. Let's just go ahead and leave those alone. But to get this -6 over here, that means that we're going to need one positive and one negative number. Okay. Now don't think too much about which one's positive, which one's negative. Just go ahead and just choose 2 factors, like 3 and 2. Like 3 and 2 makes 6, right? And just make one of them positive and one of them negative. We can always change them later. Now, if we go ahead and check these out, we want to get this +17 in the middle. If we go directly across, this is going to be +9 and a -2. So 9 minus 2 is going to be 7, which isn't 17. If we go diagonal, this is going to be -6 and +3. Those combined are going to be -3x, which is also not what we're looking for here. Now we can't change the 3x and 1x because 3x squared had those as our only factors, but for the -6, let's go ahead and change those to maybe a 6 and a 1. If we go ahead and check this out now, this is going to be +18 and -1, which 18 minus 1 is 17. So we know that this is going to be a positive and this is going to be a negative. So that means we can go ahead and say that the pairing would be this 3x and +6 and the 1x and -1. Let's see what this would be looking like if we factored it. So we're going to write 3x in the first binomial and then just 1x in the second binomial. The 3x we said was going to pair with this +6 and the 1x was going to pair with this -1. So these would be our outer pairing and this would be our inner pairing. Let's go ahead and check this. So 3x times x, that's going to be 3x squared. The outers are going to get us 18x and the inners are going to get you a -1x. And then if we go ahead and check the last one, -1 times +6 is going to be a -6 here. Combining this 18 and -x, we're going to get 3x squared plus 17x and then -6. All right, that would be our factor form, and it looks like we did a good job. Let's go ahead and see number 14, where we have 2x squared plus 11x minus 40. So for this 2x squared, we like how 2 is prime, so it's going to be 2x and 1x. And then for this -40, let's see, we need one positive, one negative. So I think 8 and 5 are the closest factors to each other. And again, don't worry about positives and negatives. Let's just choose one negative and one positive, and we can always change them later. We're looking for positive 11. So if we multiply these, that's -16 and a +5. -16 plus 5 is -11. So we're looking for +11. And so this is actually pretty good because we can just go ahead and change these signs. Let's make this a plus and this a minus. And I think this is going to work out because now this is going to be a positive 16 minus 5, which is that positive 11. So let's go ahead and write this out. So 2x is going to be the beginning of this binomial. Then 1x is going to be the beginning of this one. 2x is pairing with this 8, and the 1x is paired with this minus 5. So let's go ahead and see if this works out, but these are the pairings. And let's go ahead and FOIL to see if this makes sense. So 2x times x, that's this 2x to the second power. Let's go ahead and check the outers and the inners now. The outers are going to get you a positive 16x. The inners are minus 5x. And then finally, this negative 5 times 8 is going to be a negative 40. Finally, combining these like terms in the middle, let's see, we're going to have 2x squared, then plus 11x, and then minus 40. I think this is what we were looking for, so we did a good job factoring. For number 15, we have 5x squared plus 33x minus 14. I do like this prime number of 5, so we know this has to be 5x and this has to be 1x. That doesn't change. Now 14 is also pretty nice because it doesn't have too many factors. I'm going to start with maybe 2 and 7 here. So 2 and 7. I'm going to go ahead and see, just make one positive, one negative. And let's go ahead and just try this out. So this is going to be positive 10 and a negative 7. So 10 minus 7 is 3. That's not what we want. If we go diagonal, this will be negative 35 plus 2. Negative 35 plus 2 is negative 33, which is good because we want positive 33. So we just have to change the signs here. So let's make this a negative 2 and a positive 7 and go back to pairing them up the way we just did. So this is going to be positive 35 minus 2. And that's 33. So let's go ahead and write our binomials. So factored, I think we have a 5x here, and then we have a 1x. 5x is paired with a positive 7, and then the x is paired with a minus 2. Go ahead and checking this. This will be our outers and our inners. Let's go ahead and see if this makes sense. So 5x times x, that's going to be 5x to the second power. Then let's go ahead and check the outers and the inners. On the outers, we're going to get positive 35x. On the inners, we're going to get minus 2x. And then finally, this negative 2 times positive 7 is a negative 14. In the middle, if we combine these, we're going to end up with this 5x to the second power. Then we're going to go ahead and see that 35 minus 2 is going to be positive 33x. And then we have a minus 14. Okay, so this seems to be what we were looking for, so we factored correctly. If we look at 16, we have 9x squared plus 22x minus 15. Unfortunately, 9 is composite, so it could be 3 and 3 or 9 and 1. Let's start with the ones that are closer together. So it's going to do 3x and 3x. And then for this 15, it doesn't have too many factors, but let's do maybe 5 and 3 to start with. And I'm just going to make this positive and this negative to start. Okay. If we go across, this will be positive 15 minus 9, which is going to be positive 6. We want 22 though. If we go diagonal, it's not going to change because the 3x's are still 3x's. I could make the 5 and 3 into a 15 and a 1, but I'm going to go ahead and try making the 9x squared. Let's go ahead and make that 9 and 1 instead and see how that works. Your choice though. If we go ahead and go across, this will be positive 45 minus 3, which is positive 42. That's not what we want. If we go diagonal, this is negative 27 plus 5. Negative 27 plus 5 is negative 22, so we're very close here. Let's go ahead and just change the signs. Let's make this a negative 5 and a positive 3. I think if we go ahead and pair this up again, positive 27 minus 5 is positive 22. Okay, so I think we have what we need. This 9x is going to be the beginning of this binomial, and then 1x is the beginning of the next one. The 9x is pairing with a positive 3, and the 1x is being paired with a minus 5. So here are the outers and the inners. Checking this, let's go ahead and FOIL. 9x times x, that's going to be 9x to the second power. If we go ahead and check the outers, then check the inners, the outers are going to get us 27x. The inners are going to get you minus 5x. And then the last is going to be minus 15. If we go ahead and combine these like terms in the middle, then we're going to have 9x squared plus 22x and then minus 15. So this seems to work out. And so we factored correctly. For number 17, we have 8x squared plus 21x minus 9. Now 8 is composite, so we have a couple choices here. I'm going to start with the two closer factors, 4 and 2, so 4x and 2x. And then for 9, let's go ahead and just do 3 and 3. And we have to make one positive, one negative. All right, if we go across, it's going to be 12 minus 6, which is 6, not what we want. If we go this way, it's going to be negative 12 and positive 6, so that's going to be not what we want either. Let's see, I'm going to choose to change the 3 and 3 to 9 and 1 here, see if this works. If we go across, this is going to be 36 minus 2, which is 34, not what we want. If we go diagonal here, that's negative 4 and positive 18. That's going to be positive 14, not what we want either. Let's go ahead and change this 4 and 2 to an 8 and a 1. Let's go ahead and change this 9 and 1 back to a 3 and a 3 and see what happens here. So this will be positive 24 minus 3. 24 minus 3 is 21, so that's what we're looking for. So let's pair the outers and the inners. First one will have 8x at the beginning. The next binomial will have 1x at the beginning. 8x is being paired with a positive 3, and the 1x is being paired with a minus 3. So the outers are right here, and the inners are right here. Checking this, 8x times 1x is going to be 8x squared. Let's go ahead and check the outers now and the inners. For the outers, I think that's going to be 24x. For the inners, it's going to be minus 3x. And then for the last, if we go ahead and multiply negative 3 and positive 3, that makes negative 9. Going in and combining these like terms in the middle, we're going to have 8x squared, then plus this 21x, and then minus 9. Cool. Last one of these types, where all our b values are positive and our c values were negative. For 18, we have 12x squared plus 44x minus 45. Now 12 has a lot more factors, but I'm going to start with a 4 and a 3. And then 45 also has a bunch of factors, but I'm going to start with maybe a 9 times 5 to get 45. And I'm going to make this one negative, this one positive, and let's go from there. This is negative 36 and positive 15, which combine to make negative 21, not what we want. This is positive 20 and negative 27, so that's going to be negative 7. That's also not what we want. Okay, let's go ahead and change 4 and 3 to 6 and 2. If we try these new set of factors here, we're going to get negative 54 and positive 10, which makes negative 44, which is really good for us, because now we just have to change the signs and make this a positive 9 and a negative 5. So if we go ahead and combine these again, this will be positive 54, take away 10, which is positive 44. So let's see, we have 6x for our first binomial beginning, and then 2x over here. The 6x pairs with a positive 9, and the 2x pairs with a minus 5. So here are the outers and the inners. Let's go ahead and check this. 6x times 2x, that's going to be 12x squared. Good. And then the outers and the inners. For the outers, we're going to get 54x. For the inners, we're going to get minus 10x. And finally, negative 5 and positive 9 is going to be negative 45. Combining these two terms in the middle, we're going to get 12x squared, and then we're going to get this positive 44x in the middle, and then a minus 45. Cool. So you did a good job. Let's check out this last type of case. For these last ones, they're very similar actually to the ones we just did, like case number 3. So let's check out case number 4, where A is still positive, so that's the same for all the cases right now. And then you can see here that B is going to be negative and C is negative. So we're looking for things to add in the middle to get a negative instead of a positive now. So for 19, we have 3x squared minus 17x minus 6. So 3x squared is nice because it's prime. So we have 3x and 1x, that's going to stay there. And then for this negative 6, let's go ahead and choose one negative, one positive. So I'm going to make this a negative 3 and a positive 2. We're looking for a negative 17 here. So if we go across, it's going to be negative 9 plus 2, which is negative 7, not what we want. If we go diagonal, it's going to be positive 6 minus 3, which is going to be positive 3. That's also not what we want. The 3x and 1x have to stay the same, but this 3 and 2 can change to a 6 and a 1. Going across here, we have negative 18 plus 1, which is negative 17. So we found our pairs. So let's go ahead and write our binomials. We know 3x is going to start this one, and then 1x is going to start the next one. 3x is paired with a minus 6, and the 1x is paired with a positive 1. So let's go ahead and check. These are outers, these are inners. If we go ahead and FOIL it out, 3x times x, that's going to be 3x to the second power. Let's go ahead and check the outers and the inners here. For the outers, it's going to be negative 18x. For the inners, it's plus 1x. And then for the last here, 1 times negative 6, that's going to be negative 6. If we go ahead and combine these two middle terms here, we're going to get 3x to the second power minus 17x minus 6. Cool. So we factored this one here. And let's try a few more. So for 20, we have 5x squared minus 1x minus 22. So let's see here. 5 is prime. We like that. So it's 5x and 1x. For negative 22, we have 2 and 11, or 1 and 22. Let's go with 2 and 11 here and do 1 negative, 1 positive. I don't really think too much about those. If we go across, that's negative 10 and positive 11, which makes positive 1x, but we want negative 1x, right? So let's just change the sign, make this a positive 2 and a negative 1, negative 11 rather. And so if we go across, that's positive 10 and negative 11, and that makes negative 1x when you combine them. So let's go ahead and write our binomials. We have 5x and 1x. Then the 5x is being paired with this positive 2. And the 1x is being paired with this negative 11. So our pairings are the outers and the inners that look like this. If we go ahead and check this by FOILing, 5x times x, that's going to be 5x to the second power. Then for the outers and the outers we should get positive 10x, the inners we should get negative 11x. And then finally, negative 11 times positive 2 is going to be negative 22. Combining these in the middle here, we're going to get 5x to the second power, and then minus 1x, or just minus x, and then minus 22. You don't have to write the 1 if you don't want to, but sometimes it just helps us see that coefficient. Cool, let's check out a few more. Here is number 21. For number 21, we have this 2x squared minus 3x minus 14, so 2 is prime, which is nice. This 2x and 1x are going to be the beginning of the binomials. Then for this negative 14, I'm going to do a 2 and a 7 here, and I'm going to make the 2 negative and the 7 positive and adjust as necessary. So this will be negative 4 and positive 7, which combines to make positive 3. We want negative 3, so we're on the right track. All we have to do is make this a positive 2 and a negative 7. So if we do that, we can pair this up and say this is going to be 4 minus 7, which is negative 3, and we're good to go. So we have 2x, and we have 1x. 2x is being paired with this plus 2, and the 1x is being paired with this minus 7. So you can see our outer pairings and our inner pairings. Let's go ahead and check this. 2x times x, it's going to be 2x squared. Then check the outers and check the inners. For the outers, we're going to get plus 4x. For the inners, we're going to get minus 7x. And then finally, for the last, negative 7 times positive 2 is going to be negative 14. Let's go ahead and check if we combine these in the middle. If we do so, we're going to get 2x squared minus this 3x minus 14. All right, cool. This worked out. Let's try just a few more. For 22, we have 12x squared minus 23x plus 5. So sorry about that, but this looks like we have a positive 5 here, so this one snuck in here. That's my bad. But let's see if we can factor it anyway, but just notice it doesn't really fit with the rest of these cases that we have here in this category, but we can still factor it, I think. 12x squared, that's not going to be prime, so that's a little bit more annoying, but let's go ahead and choose maybe 4x and 3x because they're closest together. Then for this positive 5, so if you're paying attention, you need to know that we need 2 negatives here. So at least it's prime, right? So negative 5 and negative 1. The reason why we know that they have to be both negative is because 5 is positive, but this 23 is negative. If we go ahead and combine across here, this is negative 20 and negative 3, and those combine to make negative 23. So maybe this is a good reminder that this is going to be in that case number 2, where we have a positive c but a negative b value. So sorry if that's a little confusing, wrong category. So let's do 4x at the beginning here and 3x over here. So 4x is going to pair with a minus 5, and then the 3x is going to pair with a minus 1. So here are the outers and the inners. Let's go ahead and check this. 4x times 3x, it's going to be 12x squared. Then if we do the outers and the outers is going to be negative 20x. The inners is going to be a negative 3x, so it's going to put minus 3x. And then this negative 1 times negative 5, 2 negatives multiply to get a positive. Let's go ahead and combine those like terms in the middle. Combining this, we're going to get 12x squared, and then minus this 23x, and then plus 5. So even though this was a different case, it snuck in here. Maybe it's just good to see if we still knew how to factor another case. All right, here is number 23. Last two. For 23, we have 9x squared minus 41x minus 20. 9 could be 3 and 3 or 9 and 1. I'm going to start with 3 and 3, 3x and 3x. Then for negative 20, we have lots of choices here, but let's go with maybe 5 and 4. They're the closest together. And so it's a negative 20, so I'm going to do a negative 5 and a positive 4. If we go across, that's going to be negative 15 and positive 12, which is negative 3 when you combine. Not what we want. We can't even go diagonal here just because it's not going to change anything with the same 3 and 3. Let's maybe change the 5 and 4 to maybe a 10 and a 2. See if that gets us what we want. It's going to be negative 30 and positive 6, which is going to be a negative 24. Still not what we want. Maybe we can try 20 and 1. If we go ahead and change this, let's do 20 and 1. If we do that, then we're going to end up with negative 60 and positive 3, which is going to be negative 57. Also not what we want. Let's go ahead and try changing the 3 and 3 to make a 9 and 1. And let's change the 20 and 1 back to something like 4 and 5, where we started with. If we do this one, we're going to get, let's see, negative 36 plus 5. Negative 36 plus 5 is going to be negative 31, not what we want. If we go diagonal though, that's going to be positive 45. Positive 45 minus 4 is going to be positive 41. And we want negative 41, so I think we're pretty close here. Let's just make this a positive 4 and a negative 5. So if we go ahead and check this again, this will be negative 45 plus 4, which is negative 41. So we have a 9x at the beginning of this binomial and a 1x over here. The 9x is going to pair with a minus 5, and the 1x is going to pair with a positive 4. So checking this, our outers are over here and our inners are over here. 9x times x, that's going to be 9x to the second power. Then our outers and our inners. For the outers, we're going to get negative 45x. For the inners, we're going to get plus 4x. And then for the last 5 times, negative 5 times 4 is going to be negative 20. Combining these two in the middle, we're going to get 9x squared, then minus this 41x, and then minus 20. And this seems to be what we started with, so we must have factored correctly. All right, last practice problem here, and trying this case number 4. We have 18x squared minus 33x minus 40. 18's got a lot of factors here. I'm going to start with 2 closest, which is going to be 3x and 6x. Okay, and then we have this minus 40 here, which also has a lot of factors. I'm going to start with 8 and 5, just because they're the closest together. And I'm going to make this a negative and a positive, and then we'll change it if we need to. This is going to be negative 24 and a positive 30, which combines to make a positive 6. That's not what we want. Then if we go across or diagonal, it's going to be positive 15 and a minus 48, which does actually get you that negative 33. So 15 minus 48 does equal negative 33, so that works out nicely. So we're going to have this 3x at the beginning of this binomial, then a 6x over here. 3x is going to pair with a positive 5, then the 6x is going to pair with a minus 8. So here are the outers and here are the inners, and let's go ahead and check this. So 3x times 6x, that's going to be 18x squared. Check the outers and inners here. For the outers, we're going to get positive 15x. For the inners, it's going to be negative 48x. And then checking the last, negative 8 times 5 is going to be negative 40. Combining these two like terms in the middle, we're going to end up with 18x squared minus this 33x and then minus 40. So this is another one that worked out for us. Okay, so there you have 24 different practice problems on factoring trinomials where a was greater than 1 or a was not equal to 1 here. Keep in mind the 4 different cases, and hopefully this strategy helps you out with just factoring these trinomials a little bit quicker. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.